I've graphed the function f of x, and let's assume that f of x goes on forever downward and to the left, and also upward and to the right. I've also used graphing calculator software to calculate some of the important points on this curve, and those are some of the points we're going to talk about. We're going to evaluate or analyze this curve for the different items that you see listed on the left and the right hand side of the curve. First of all, you should see the x-intercepts, negative 5, 0, negative 2, 0, and 3, 0. Also, we have a local maximum or a relative maximum at the point that the curve has a peak at negative 3.67, 2.96. I'm going to write that down for relative maximum. Relative maximum relative to the points in the area, it's the highest point, or we also can call it the local maximum. We have a relative minimum or a local minimum at the point 1, negative 7.2. The minimum value is actually negative 7.2. It occurs when x is 1. Same thing with the relative maximum. The maximum value is 2.96 at an x value of negative 3.67. Knowing these points, we can identify parts of the curve that are increasing or decreasing. We discuss increasing and decreasing as we move from left to right, and we express the intervals in which the curve increases or decreases with x values. We're talking about the y values increasing or decreasing, so we express how they increase and decrease according to the x values. So understanding again that this curve goes forever downward and to the left, it's going to the left forever, so it begins to increase from negative infinity until it reaches an x value of 3.67. Let me change this to a parenthesis. So it increases until it reaches that point of negative 3.67. The curve from left to right also increases from 1 to infinity. So from the point 1 comma negative 7.2, it goes upward from there, and so from x value 1 until we go all the way to the right off to infinity, the curve is also increasing. The curve decreases when it's going downward from left to right from an x value of negative 3.67 to an x value of 1. On the right-hand side of the graph, I have f of x is greater than 0, which means the y values are greater than 0, or the curve is above the x-axis. This occurs from an x value of negative 5 to an x value of negative 2. It also occurs from an x value of 3 off to infinity. Down below, we have f of x is less than 0. Where's the curve under the x-axis, where the y value is negative? That occurs from negative infinity until we reach an x value of negative 5, and also from an x value of negative 2 to an x value of 3. So those are some of the important aspects of this curve, some of the important characteristics. I want to give you another curve to analyze. This curve is called g of x. Do the same things that we did with the other curve. Pause the video, write down your answers, and then come back to the video to check your answer. In this curve, we can see that there's a peak at 6.15, 1.05. So we have a relative maximum there. We have a lowest point for part of the curve at negative 2.81, negative 6.17. Notice that these points are not the absolute maximums or minimums, because the curve goes up and down forever, but yet they're relative to the points around them. The curve increases from an x value of negative 2.81 to an x value of 6.15. The curve decreases or goes down from left to right from negative infinity to an x value of 2.81. It also goes downward from an x value of 6.15 off to infinity. Again, we're talking about the y values either increasing or decreasing as we go from left to right. On the right hand side, g of x is greater than 0. Where are the y values greater than 0? Where's the curve above the x-axis? To the left, we have the curve above the x-axis from negative infinity until we reach negative 7. We also have the curve above the x-axis from 4 to 8. Down below, g of x is less than 0. Where's the curve below the x-axis? This occurs from negative 7, from an x value of negative 7 to an x value of 4. And it also occurs from an x value of 8 off to infinity. These are some of the important characteristics of a function. Be aware of or be knowledgeable on how to use a graphing calculator to calculate some of these values. Some of these are estimates that come from the calculator. Others are exact values, like the x-intercepts happen to be exact values. But know how to use your calculator to locate these points, and then know how to express these important characteristics in interval notation from left to right, using the x values, expressing your answers in x values because you're talking about the y values.